Weather observing is at times walking outside to look at the clouds and the weather, and to read some instruments. Some instruments can be located inside the building. After recording the results, we can send a message out to other officers. At these other offices, weather observers are involved in plotting the information onto charts so that meteorologists can analyse the results to produce a forecast. As well as surface observations, upper air observations can also be performed. Optical theodolites can track balloons filled with hydrogen as they ascend through the different wind layers. From the path the balloon takes, we can compute wind profiles above the station. Larger balloons may also carry a radar reflector to enable automatic tracking beyond clouds and to ranges of over 100 kilometres. These balloons can also carry radio sondes, which relay information on temperature, humidity and pressure. It is the observer's job to operate the radar equipment and the radio sonde recording units, and also to carry out the calculations that are necessary to reduce the data to a form suitable for meteorologists. We can see that weather observing is not as simple as walking outside to look at the clouds. The more you get into it, the more it is changing and evolving, just like the weather. Very few things are as simple as they first appear. Weather observations are not only made on a nice, fine, sunny day, but may occur in the middle of a cold, dark night. The yellow coat, well, it was raining. The inclinometer and a searchlight shining on a cloud base will give me a height of that cloud base. Upper wind flights are also conducted at night time, and several types of radar may be used. This older WF2 radar is a manual follow radar, the tracking being done by an observer in the cabin responding to changes in the signal on the display. Either the observer can push the unit from outside or wind on hand wheels inside the cabin. Each radar has its own operating system, its own switch-up procedure and its own check procedures. Locating balloons in darkness and rain can cause some problems. Some radars can be used for weather watching as well as for automatically tracking balloon-borne targets. Information collected and sent out in messages must adhere to international coding standards. Messages sent out on punch tape are often fed over landline straight into computers and must adhere to standard formats. Details plotted on charts include wind direction and speed, barometric pressure, barograph tendencies, temperatures, dew points, present and past weather, visibility, cloud amount, height, and any one of 30 types, information on the sea, and even ship observations. 17Z, that's the time of the chart in Greenwich Mean Time, 3 AM Eastern Standard Time. Many people have been out and about recording information and sending in messages. In a typical regional forecasting centre, we can see a group of meteorologists, each with their own forecasting responsibility, such as public weather forecasting, aviation, etc., coming together to discuss developments in the last few days. Observers work in such an office. Melbourne's weather details are recorded here to answer any telephone inquiry. In some offices, weather observers may be responsible for relaying forecasts to pilots. Now, it isn't just for cold days that we put coats on. This is part of our safety procedures when we are using hydrogen. Serious explosions have occurred with weather balloons, producing quite a dangerous fireball. This coat is designed to protect the observer, hanging below the knees. It has a hood, a face flap. We wear goggles and gloves, so that if you are unlucky enough to have an explosion, you can requisition for a new coat, but you can't get a new set of eyes or hands. Spraying water around the shed increases humidity and reduces the chance of static charges. We don't want you to be a casualty, like this chap down here. At times we have to manufacture hydrogen on the station, where there are no commercial deliveries of gas. We use caustic soda and ferrosilicon and a bucket of water. Mix these together in a cylinder and you get quite a violent reaction. As usual, overalls, face masks, rubber boots, these are the safety clothes that we use. That reaction generates quite a bit of heat. I'm glad this one's under control. Safety procedures are like road rules, designed to keep you from hurting yourself. The weather is always changing. Clouds develop and dissolve, or they can bring rain and other changes. These are the sort of things that weather observers are trained to do, to reduce this three-dimensional picture into data for use by other people. Weather observers are located at about 70 stations around Australia and in Antarctica. Sometimes conditions are quite harsh. Family and friends can be a long way away, and we were probably working shift work, part of a 24-hour watch, with few weekends off. How would you like Giles in Central Australia? Out the other side of Ayers Rock, just after you cross the Western Australian border. A wide range of duties to be carried out in a wide range of places. Our training is designed to give you the skills to cope with life as a weather observer.
Cold with occasional showers. Today's top temperature 20 degrees with a low overnight of 14 degrees. Further north, if we look at the weather chart, we're going...
Simple, isn't it? Today's going to be fine and mild with light northwest winds freshening late this afternoon ahead of a cool change. The outlook for Wednesday is cold with occasional showers. Today's top temperature 20 degrees with a low overnight of 14 degrees. Most of us listen and take note each day of the weather forecast. It affects what we wear, our work, our leisure, what we eat. In fact, if you think about it, the daily weather forecast plays a vital part in our daily plans for life. This program is one of a series produced to give you an insight into various types of technical occupations available in the workforce. In this program, we'll be focusing on two jobs that provide technical support for the forecasting of weather: the observer and the technical officer, meteorology. In Australia, there is one employer for observers and technical officers, namely the Bureau of Meteorology, which is part of the Commonwealth Department of Science and Technology.
The overall activities of the Bureau involve the provision of a national weather service. The Bureau has responsibilities to the Commonwealth for the provision of services which range across research into aspects of meteorology, data storage which can be used by other organisations, and its most visible activity, which people are generally aware of, is the provision of forecasts and warnings to the general public, the aviation industry and the marine users. The observer and the technical officer meteorology fit in across the complete range of these activities. They're mostly concentrated in the provision of services to the aviation industry, but they also perform functions in the provision of service to the general public and also to the marine interests as well.
Observers are found in field stations which are spread across the entire country, as well as selected offshore islands and Antarctica. They also work in regional forecasting centres, which are located in all state capitals, Canberra and Darwin, and at weather service offices at major city airports, which include those used for domestic, international and light aircraft, as well as most RAAF bases. Technical offices are located at airports, regional forecasting centres, and at the head office of the Bureau of Meteorology. At field stations, observers take surface observations using a variety of equipment, including thermometers and rain gauges, as well as other instruments. The observer makes estimates of visibility and observes cloud cover, types and heights, and describes present and past weather conditions, and then communicates the observations in code to the regional forecasting centres. Upper air observations are also made using a variety of equipment, including radar.
I'm a trainee weather observer and I work for the Bureau of Meteorology. At present I'm completing my 17 weeks of on-the-job practical training at a field station. The field station that I'm working at is at the RAAF Air Force Base at Laverton, and we provide information for not only the Air Force and the pilots and civilian pilots that are flying in the area, but also to the regional centres with the Weather Bureau and all around Australia. Our normal day's work, it's a 24-hour rotating roster and it depends on what time we come on duty, but the normal duties involved are a 3-hourly weather observation, which involves readings of temperature, humidity, clouds, general weather view, atmospheric pressure, the wind direction and speed, whether it's rained, temperature of the soil. That's done every 3 hours. Also, we do a 6-hourly balloon flight, which involves releasing a balloon and tracking it by radar and following it, which gives us readings of the wind speed and direction through the atmosphere. With 2 of the flights, we send up what's called a radio sonde, which sends us back radio signals giving us information on temperature and humidity as it rises. This information is good for finding out whether thunderstorms may occur, depending on how fast the air is cooling or heating as you go up. The balloon flight involves filling a balloon with hydrogen and releasing it. Now, to start with, we have to wear safety equipment, which includes what's called an anti-flash coat, cotton gloves and goggles, because hydrogen is a very volatile gas, and if it explodes, which it can, it's very dangerous and has been known to cause quite severe burns to people. So we wear all our safety gear. Depending on what time of day and how far we want to track the balloon, depends on what size balloon we use. They come in weights. We have 20 gram, 100 gram, 250 gram and so on, depending on how far we want it to go up. For the radio sonde flight, which gives us the temperature and humidity, we use a 350 gram balloon, and we have a weight system where as soon as the balloon rises, we can tell that it will lift that amount, and then we turn the gas off and tie the balloon off. On the bottom of the balloon, we have a target which reflects the signals back from the radar so that we can follow it. If we didn't have the target, there would be nothing for the radar to follow. The signals would have nothing to return from.
The radar is operated, in this case manually, with a handle to control the elevation angle of the radar, and also another handle for the azimuth, which is the direction, and also a range control. We keep tracking just by following the signal and moving the radar both in azimuth and elevation, and then the range control, and by that way we're able to take an exact reading of just what position the balloon is at each minute when we want the readings. The signal we're watching is displayed on a cathode ray tube screen, and it comes back as a circle. We can tell if we're off direction by the circle being broken, and that way we can tell when we've got a clear full circle, we're right on target, and if it's broken to the right or left, we then just make adjustments with the hand controls. The actual readings we're noting down is the exact elevation, azimuth and range of the balloon at each instant when we want to take a reading. We follow the balloon until it bursts. Eventually it expands through a decrease in pressure and it'll burst, and we'll know it's burst by a sudden drop in elevation, and the balloon starts coming down then instead of rising. After we've done this, we then take a list of all the readings and pick out certain levels and any significant wind changes and make them up into a numbered code, which is transmitted by telex to the head office, and then all those wind readings are sent to all forecasting centres that actually want that information. This is done at a number of stations throughout Australia at exactly the same time every day, and it's done 4 times a day, so that they get a consistency in readings and can then put it into proper forecasting situations.
In the case of field stations located at airports, the information gathered by the observer plays a vital role in the activities of the technical officer.
I'm a technical officer with the Bureau of Meteorology at a major city airport, involved in the briefing of pilots and meteorological information pertinent to their flights and air routes throughout the country. Our job also involves in the collation and the examination of observational data to assist with the briefing of pilots. The day for a technical officer in the major airport starts very early in the morning, generally at 5 a.m. This gives us time to get the forecast ready for the air pilots when they come in for their early morning flights. Generally the pilots are in here at 6 o'clock for their briefings. This gives us time to collate the information from all around Australia and overseas to present to the pilots. It gives us time to familiarise ourselves with the weather patterns, the upper air flows and any disturbances that are likely to affect the pilots and the aircraft en route. This information they then, as part of their cabin brief to the passengers, part on the information we've given to them for concerning their terminal or their destination weather. Mostly our information comes from observational data that comes in on teleprinters and an aeronautical teleprinter, which gives us the information we can put together in the form of a plot. This plot is then analysed, and in conjunction with a plot from the upper atmosphere, we can then determine the suitability or the weather that they're likely to encounter on their trips. The local weather observer at the major airport is the eyes of the Weather Bureau. He's the one that informs us of any impending weather or current conditions. He's the one that determines the actual conditions at an airport, from which the technical officer then decides on the local area forecast. As a technical officer with the Weather Bureau, we rely completely on teamwork. We must be able to communicate and rely implicitly on the observations we receive from the observers. We must liaise very closely with senior air traffic controllers, particularly if there's a search and rescue going on. We must be able to liaise very closely with the regional forecasting centres, indicating areas that need amendment or change, and we must be able to relate very closely to pilots. So the whole system relies very, very much on teamwork.
So observers at airports provide meteorological observations for the technical officer as well as regional forecasting centres. Using these observations, technical officers formulate a short-term forecast which they use to brief pilots. These forecasts are also important in determining the amount of fuel that aircraft carry to safeguard against adverse weather at their intended destinations. Technical officers who brief pilots of light aircraft need highly developed briefing skills, as some pilots may only fly occasionally and their aircraft are more susceptible to adverse weather elements. At the regional forecasting centres, the observer and technical officer work with meteorologists who interpret the observer's findings and provide the longer-term forecasts.
Part of my job is to plot surface and upper atmosphere charts, and the information for these charts is received by our communications system in the form of coded messages, which are coded according to an international code. The elements plotted on these charts include wind, temperature, dry bulb temperatures, wet bulb temperatures and dew point temperatures, which give an idea of the relative humidity of the atmosphere, present weathers, past weathers, cloud formation, height and type. The area that is covered by the charts in our situation is the Greater Australian area, and also ocean areas that are liable to affect the weather as it occurs in the Australian region. One of the properties of rainfall is its ability to reflect rain radar echoes. Radar observation consists of establishing areas of rainfall, the rates of rainfall within that area, the rate of movement of that particular area. We also measure the height of rain-bearing clouds, and this information is used by forecasters in the provision of short-term advices to the aviation industry and other users.
Once the observer has plotted his observations gathered from the coded messages received from other observers around Australia and his own local observations, he passes the information to the meteorologist for analysis. The meteorologist then makes his forecast and passes it to the technical officer.
My position is as a technical officer with the Bureau of Meteorology. I work at the Regional Forecasting Centre. My basic role is to pass on weather information, both forecast and statistical, to members of the public or the media or any other person that might inquire. Most of my work is generated by meteorologists. They prepare the forecasts and pass them on to us. From that point, we answer telephone calls. We meet people face-to-face over the counter, and we pass information on to the media. The wide range of the community approach us via the telephone. We get calls from just the ordinary citizen wanting to plan a barbecue or a wedding, any other outdoor function, or sporting people. We generally get on average about 300 to 400 phone calls a day. This can run up to as many as 800 or 900 when exceptional weather has occurred. We get quite a few people coming into the counter each day, probably 10 to 15. Generally it's an ordinary citizen who might want just some statistical information to buy a property somewhere. He wants to know what the rainfall in that area is. So we'll then research our records and make photocopies and provide him with the information he requires. Each day we prepare satellite photographs and weather charts for the media to use in their television presentations. We would also include statistics as to the temperatures around the state, rainfall around the state on each day, and copies of forecasts prepared by the meteorologists.
Technical officers therefore work in aviation and information, but they are also found in other areas of the Bureau of Meteorology.
I'm a meteorological technical officer. I work for the Weather Bureau in head office Melbourne, specifically in research and development branch, and we are involved in meteorological research in all its aspects. I work for or in support of professional meteorological staff. Most of the work comes direct from them in specific research projects such as tropical monsoon and tropical cyclone studies. One of the projects we're involved in at the moment is producing better pictures from satellite data, specifically looking at tropical cyclones and trying to determine exactly where the centre of the cyclone is from a picture. The project I'm involved in at the moment is one of computer analysing, if you like, a satellite, a full satellite picture, and in that we artificially colour, if you like, or shade particular cloud features so that we can see what's going in more clearly in that particular area. The one application of tropical cyclone is to find the eye, pinpoint it exactly geographically so that we can plot speeds and directions and predict landfall. By landfall I mean the point and time at which the tropical cyclone will actually cross the coast. We get about as many as 15 or 20 tropical cyclones in a season, but of course not all of them cross the coast and become a hazard to the public. We know that particular colours correspond to particular temperatures which relate to the cloud height in the atmosphere, and we can then visibly depict the eye wall of the cyclone and therefore infer where the eye is, and in doing so we've in effect pinpointed the centre of the tropical cyclone very accurately.
So technical officers work in research as well as computer data quality control, where they're involved in the vetting of all information relayed to the computer, which provides a number of printouts, including weather maps, showing the weather conditions on a national and hemispheric scale. In the occupations we're considering, it's normal for people to join the Bureau of Meteorology as observers.
Our recruitment campaigns are conducted Australia-wide. We advertise through the normal Commonwealth channels and in the daily press, and we send recruiting teams to all the capital cities where we interview people and determine their suitability for positions in the Bureau. This is for the initial selections as observers. We then bring them here to Melbourne for the actual training program, and of course they get the normal Commonwealth assistance so that they can make that move without any cost to themselves. Again, when we get to the situation of bringing these people back subsequently after a few years' experience to come back and do a course as a technical officer in the Bureau, again we advertise nationally so that all the observers who wish to can be considered. We conduct interviews all around Australia, and again we provide assistance in the form of the normal sorts of entitlements that Commonwealth public servants get to come back to Melbourne and undertake the training program. So it is a national campaign in each instance that we conduct, and they are in each instance brought back to Melbourne for the full training program. Yeah, on the training and development of observers and technical officers really should be seen as being two separate stages in the development of the one sort of person, I guess. We take people who have got Year 11 qualifications into the Bureau of Meteorology. They can be school leavers. In many cases, they're not. Some people have come to the Bureau as an observer after they've already had some employment. The sorts of qualities we're looking for are not solely academic. We want people who have got certain scientific skills and ability, and we want Year 11 qualifications in the maths and physics area. But there are certain personal qualities which we think are very important for observers. The sort of lifestyle needs a sort of independent-minded person, the sort of person who likes to work outdoors, the sort of person, I guess, who likes a little bit of freedom and independence in how he goes about his normal duties. And also, I suppose, and this is very important, a certain responsibility, because they are working in remote sorts of areas away from a lot of controls, and they do have a very responsible job. So personal qualities are a very big part of our selection procedures. Now, when these people have been out working in the Bureau of Meteorology as an observer for a number of years, we can bring them back to undertake a technical officer meteorology course. Now, their initial training as an observer has involved a 52-week training period. It was 35 weeks of classroom instruction, if you like, followed by an additional 17 weeks of experience in the field under the direct supervision of an experienced observer. When they've then completed that period of training and had that additional experience I spoke about just a moment ago, we can then ask them to come back and undertake an additional program which involves another 9 months training here in Melbourne. This second phase of training is a course which we run in conjunction with the Royal Melbourne Institute of Technology. It is stages 2 and 3 of a Certificate of Applied Science at the Institute, and at the end of that period of training they are then qualified as a Technical Officer Meteorology, and from that point they can then go out and work in the Bureau of Meteorology as a Technical Officer, supplying information direct to the Bureau's major customers. In a sense, the employment opportunities are limited once you have committed yourself to this sort of career. The Bureau is certainly the largest employer of meteorological staff in Australia. This is purely because we are the National Weather Service, obviously. But other people, such as the EPA, the SEC, the State Electricity Commission in various areas, the CSIRO, the universities, all have usage or uses for people with these sorts of skills. Now, they're very small numbers that would be able to go into those areas. So basically, once you embark on this sort of career in the Bureau of Meteorology, you are really dedicating yourself, if you like, to one employer in Australia. Meteorology, of course, is an international activity, and one which is probably the best example that there is of international cooperation. And it means that people who do get into a National Weather Service do have that opportunity to find employment in other countries. It's not automatic again, of course. You have to make application and you have to be selected, but your training in meteorology can be a useful qualification to take with you if you do happen to travel to another country.
It's important to note that it's not an automatic progression from observer to technical officer. It does require a selection process, and observers, if they wish, are able to follow an independent career path as an observer within the Bureau of Meteorology. Communication plays a vital role in the activities of the Bureau of Meteorology. The coded messages sent by observers located in field stations and regional centres, together with interpretations, quality control, research and explanation of that data to pilots, the media and the general public, conducted by technical officers, relies on an efficient communication system.
Well, the future of meteorology is one which is obviously linked very much to technology and advances in the sciences area. These aspects of our lifestyle are changing very quickly at the moment, and I guess will continue to change very quickly in the future. So it's really silly, I guess, to expect that the role of an observer or a technical officer is going to be the same in 20 years' time as it is today. They will change, but this is a feature which is part of the sciences and part of the world we live in today. So one other attribute I guess we would like to see in people who come into the Bureau now is their willingness and preparedness to be adaptable and take on new roles and take on new tasks and develop new skills as the service changes.
If you'd like further information or advice about the work performed by observers or technical officers in meteorology, you can contact your nearest Commonwealth Employment Service Job Centre.